Hello, everybody, and welcome. And I already see some people here, and more are coming. And we have Gang and Glenn and Ignacio and Joseph and Shin and Sachudari. Okay, that's wonderful. So we will be starting, a little bit slow so that other people can join in. I will share the screen and I will give you the link. Okay, so first of all, share the screen. There you are. And secondly, give you the link. The link is here. Well, where? Right here. Okay, that's the link, and what you need is a bit.ly link. So I'm giving you the bit.ly link, and I'm putting that on chat. Okay, sending it to everybody. So when you click on this link, you will see exactly what I see here in the webinar, and you can also, if the click doesn't work, you can also type it because it's a bit.ly link, a short version. All right, and so thank you very much for coming. Thank you for being here because I get at least as much benefit as you guys because you know that it's very good to be motivated, and you do motivate me. So that is what we're going to do. Now, for those people who are new, then that's a webinar dedicated to what's new in AI. And when I say what's new, I mean new things for building AI applications. So we've been running for almost 3 years. And the very first thing that people come and they ask, well, where should I start? It's been a long journey for you, and that's where you would start. You will click on what I call AI education, and if you open that, you will see a long list of things that it's a good idea to learn. Now, what that means, I don't understand, but you see the course name. Then you see what will the course be about. Then you see the link. And in majority of cases, these are links from Andrew Ng courses, but it could be any university, any book, anything. And how many of these are already here? Well, if you go by that number, it's 107. And if you go by that number, it's wherever it is in the repository. So that's one. The next is that if you go and look at that link, it will be the course itself. If you go to that link, that will be the repository where I collect all of them. So there is one repository. Let me go there. Okay, that is, for example, a database agent, and it basically can run out of the box. You need the keys, but in the requirements or in the how to run, it usually tells you what requirements are needed. So it's a nice thing. That's the difference between the course itself, where you see the show, and the lab, where you can run it with a small effort. Okay, that is number one. Number two is that we have a plan, and that's the plan. Now, today it's a little bit eclectic. You will see why, because there's so much interesting stuff going on. I wanted to mention that all of these courses are not trivial. Not one of them is something that you would know anyway. Not one of them is just blah blah from the world of journalism. But all of them are new technology, so it's amazing how much stuff there is. Now, at first glance, everybody can talk to ChatGPT, which is the major miracle. But at second glance, there is much more to learn. So I will tell you right away, I'm on the positive side, meaning that we're not enemies with AI, we're friends with AI, and each has its own purpose in life, in work, and we're still asking ourselves what we are, humans, and what our role is. Okay, that philosophy aside, the first thing that we're looking at is agentic knowledge graph construction. Now, what that is about? So first of all, if you go to this education, that will be the last one right here. And if you click here, you will see not this one, but this one. Okay, you will see what this is about. This is the second course by Neo4j. So everybody wants to be in this wonderful wave of AI, and Neo4j is no different in this sense. If you want to see what did Neo4j do before, you just search. So let's look for Neo 4 J, and you see it was 33. Now you can more or less measure the time because every line is usually a week. So 33, it's about 70 weeks ago that they had the first course. Okay, and now they have the next course, so that's agentic, of course. Everybody has to be agentic. Whatever this name means, Andrew Ng once said that if it looks like agentic and it behaves like agentic, that's probably agentic. Let's not get into the details. Okay, now I don't think I have shown much here, but it allows you to create a knowledge graph. That's the difference. So in a regular RAG implementation, you take pieces of text and just search in them. The way you search in them is, I see the hand, what you can do if you want to chat, just ask for a mic. If you want to put a comment, put it in there, but a raise hand is nice, but add to that a few words. Okay. So a regular reg implementation will take your text, break it into paragraphs, and then do the search. But the search will be not by keywords, of course. It will be by meaning, right? I think I really need to give you a quick view into the outline. Okay, that's the outline. And first of all, you get the idea of what is a graph, what's a knowledge graph. But the basic idea is that you treat your pieces of text as more than just pieces of text, and you extract some meaning out of that. It's not hard. You can break it and you can use the same AI to get the meaning, but then you assign a certain concept to that piece of text. So you're building a graph of knowledge. That sounds too grand. You're building a graph and you're adding just one more structure so that, for example, you can have pieces of legal document. Okay, and you can search them. So it sounds like a great advancement compared to keyword search, but it's still compared to think of what you can do if you put that into a structure and not only search for a text, but also to the text that next to it in the meaning, in the knowledge graph. That will be better. That's what they do. They also introduce a few things. They introduce multi-agent system, but that everybody does. They also introduce ADK, Agent Development Kit, and that's honestly, I personally saw it here the first time. So nice to know that there is such a thing as Google ADK. Again, you see that absolutely everybody, it's an amazing rush, right? Like everybody is doing something in AI. And then you want to go deeper. You want to understand user intent, which you never really planned before. You want to suggest how to build a graph of knowledge out of that, and that is knowledge graph construction. What that will be about. So I have not yet run through it. So what I'm going to do, therefore, I will say, hey, next time we really need a demo of how it works. And we will do that. Okay, right here. I'm already preparing for the next session. And if you want to add something, you will add. But right now here, I'm saying, but next week, we will do a demo. We will not do as a new course. It's not new by now. It's a week old. And so week old and wants a demo. That's the story. That's all I really want to say about that. Okay. Now, that's just because I haven't done it, but also because there is too much to talk about. The next one is you ask a question, guys. You asked a question about Milvus. Okay. So I see some chat here. Anyone familiar with knowledge graph construction? Curious how pervasive that is. So I am familiar with knowledge graph construction, and I even taught a course, but I taught a lot on. There is a new language how you search the graphs, but we'll do exactly that, Lancer. We'll do a demo. So next time, so we'll talk about what do graphs really bring, what's new. Okay, then you asked a question about Milvus, and it turns out that I'm very much ashamed, but not that much because you bring me new knowledge. I didn't know about that. So Milvus is good about a few things. First of all, it is open source and you can run it on your computer. That's not the same as, for example, mm, Pinecone that cannot run on your computer. It's only remote. And then we looked at Weaviate database, and Weaviate also wants to tie you into their cluster. So, which may be good or may be bad, but Milvus is open. Now, another thing about Milvus is that it is very, very large. Very, very large, and we're talking about billions of entries, and very, very fast in under 1 second at all times. So that's what Milvus. I really want to chat and ask that about Milvus, and it basically pointed out one more thing, that Milvus may be an overkill for quite a few applications, and it suggested a Linux-based combination of two other databases. One was in-memory database. You know what? Let's do this. If it can quickly find that previous talk about mill, then maybe it will can find. Yeah, earlier I asked what was the another one that would not be an overkill, and that was SQLite and FAISS, however you pronounce it. So good, that's wonderful. I will say that in here we also need to mention alternative SQLite plus FAISS. All right, so thank you. Definitely something to try on the next project. But isn't it amazing how much stuff there is always coming up. And that's all I will say. Your next regular implementation can be on Agentic and on VectorDB, I mean Milvus, and even on SQLite Lite. It's not like it's Lite. Okay. And let's see what the comments are. Postgre can also be used as that. Yes, that's just amazing that everybody can do that. And I see, Jake, I see that you are raising your hand, but please say something because raising hand doesn't help me. Sir, which agentic framework is mostly used by companies in the USA? That's a great question. I don't know what would be mostly used by companies in the USA. I do know that LangGraph is everywhere where I see it. But I see your wonderful alternative. So what I will do is copy your question and put it here in our next conversation. And there you are. So hopefully we will address that. In other words, I want to implement something. What should I do? And we probably had a course on quite a few of them, not all, but we had a lot of stuff on LangGraph. So thank you for the question. Uh, even though, okay, thank you, Jake. Even though I didn't quite give an answer, but it was a great question. And as you know, great questions are worth their salt and worth half of their attention. Next. Next is quantum computing. Now, I will tie it to AI in the next line, but right now, what happened is that I got an announcement that there is a new company and a course on quantum computing. Now, I am a big admirer of quantum computing, and even here, I did learn it and did teach it with depends upon whom you ask success, but that was something new, so I went there and it said that you had to jump into it and even pay $20, which I did. But that all depends upon how fast you learn. Okay, I'm there, I'm logged in, and it seems like I've done the very first step. That's what I've done. But I'll tell you one important thing is that there are three ways, I would say three ways to approach learning quantum computing. Way number one is just go to IBM. IBM Quantum Computing, they have all the labs, they invented the language. So that will be the programmer way. So kind of, I don't understand what quantum computing is, but I can program it. That's one way. Another way is also pretty much the same IBM. It's very complicated math. Just lovely if you like complicated math. And then way number three is physics. So physics is very interesting because that's where the real details are. In physics, what they do is that, we will describe how it works, but we will totally not understand why it works. And I'll give you first examples. I think it's a split, even if I just say split hole experiment in quantum physics. Okay, I hope there will be a picture, and there it is. There's a picture. So the first basic fact that all physicists will talk about is that you send the light anywhere. So what is this light? People talk about photons. Are they particles? Are they little thingies that go? And if they are, they each one will go its own way through the hole, and it will end in the the wall. There will be a ray of light on the wall. And if there are two holes, there will be two rays of light, if they are photons, if they are little particles. But some people say they are waves. And if they are waves, what you will see on the other side is not one and two rays of light, but you will see an interference, and black and white interfering here. So just measure, go do that experiment. You will see interference. You will be convinced that it is a wave. But if you then measure, somehow try to measure, like put them through a prism, then amazingly enough, you will see that they behave like particles. Okay, so we're going to use it. We'll use it in quantum mechanics. We will also use it in quantum computing, and we will say it works. I totally don't understand why it works. It seems like the photon behaves like a wave, and it doesn't decide which hole will it go through until it's time. And sometimes it behaves like a particle. So you can't even explain it, but that's the first experiment. Now the next experiment is much more photons. If they go out, but before they go out, they make an agreement that they will always be friends, best friends forever. So they may go out, and one goes one way of the universe and the other goes another way universe, and one turns to the right and the other one, amazingly enough, immediately turns to the left. So those two photons are connected, and that connection never stops, even though the distance is light years. And that shouldn't work. According to physics, it just shouldn't work, but it does. These are amazing things. So what you can do if you want, take that, and the link is there. Take that course and enjoy it, because it gives you yet another way to learn. A very simple way where, yeah, I don't understand it, but I am going to answer all the questions and get the certifications. So if I got your interest, I'll tell you what they say in the end. Okay. Meanwhile, let me do this. Let me show you the major application. That is the big thing. Okay. So the question is, so, okay, very nice. Look at that. That's what the slides do to you, but I know where to find it. So I will find it in a second. Okay, so slides. What is quantum computing? It's a very nice course and amazing things, but what I want to do is show you the major applications, because the big question is, so what are the applications? Now, if you know any good application of quantum computing, then tell me, because I'm showing you something, and I'm making the major claim there are no practical applications of quantum computing. With all of the noise and all of the hullabaloo and however you call it, with all of that and all the countries in a rush to get into quantum computing, with all of that, there are today no practical applications. Okay, and even public companies who do that. So at least I'll show you most promising applications as of today. That's what I'm showing you. So number one, design new materials and drugs. Now, why is that? It's because designing new materials and drugs depends upon the materials, and they're very hard to emulate on a classical computer. So the idea is that if our computer, if it acts like real photons and electrons, maybe we can really design them in parallel. We're not going into how exactly quantum computing works, other than it is built on exactly that. It's built on photons, it's built on the electrons, and as this wonderful course explains, it looks pretty big on the outside. So quantum computer, show me a picture. That's one of the most impressive. Oh, that one is looks good, right? Yeah, that's what the quantum computing looks like, but it's all appearance. It needs a place to live in, but really what works inside are little electrons, photons, or other particles. Okay, I showed you that, and we were talking about a new course in quantum computing published by Quantum uh, called Black Opal. Okay, but I'll give you something. So first of all, we need to go through these. Now, one second. Through here, these applications. Another one, optimizing transport and logistics networks. Now, at that point, you realize that quantum computing is not for everyone in the sense, not for every vertical. It's not a generic computer that works fast. No, but it can imitate some very complicated problems, and that's where it has a chance to work better than the classical computer. So another one is pricing financials because it can imitate all the myriads of possible combinations, managing risk and improve training efficiency and artificial intelligence. Okay, we came to what I really wanted to talk about, and that would be can you combine AI and quantum computing? And if so, how? I'm making a pause to look at your comments. Okay, so here are the comments. Wow, it's very interesting what you are saying. So first of all, so Steve asks CAG versus RAG. Let's do that. I agree that it's a good question, and I'm putting it for the next week because right now, honestly, unprepared. No, I cannot talk about it, but I will be able next time. So here you are, and we're adding it to what we're going to talk about. One more. Okay, now cool quantum computer learning site. Yes, it is, and that's what Reddit said. Before I spent a whole $19, it was 19, not 20. I investigated, and 25,000 people said it's something good. Okay. Uh, okay, so a recent meeting on quantum computing, agent development, and AI startup. And how can you get a role? That is a very good question. Let's do this. Let's go to the end of the comments, but then come back to your comment. Sacho Dari, okay? Houston Museum of Natural History has a mock-up quantum computer. I was there just a couple weeks ago. I took my kids there and my grandkids, and I forgot to look at that. So next time I absolutely will. Quantum computing in one sentence, and that sentence belongs to Richard Feynman, is let us build our computers on elementary particles because those particles behave in such a way that you can't even imagine. Nothing is normal. It's all against common sense. And if we want to imitate and calculate something in that area, well, let's use the particles. Yes, and many museums have the double slit experiment. Awesome, but let me get back to Sochadari. How can you agent developer role in an AI startup? I've already completed learning all of that, ML, DL, NLP, and completed blockchain. Now, I'm risking something, but so should I. How about if you send me a resume? Because I'm talking about that with a friend of mine who is similarly running exactly that. So just send me a resume, okay? I'll give you my email, or maybe shorter one, skaya.com. But a general advice would be just keep doing what you're doing and something will happen. But the more specific maybe will come. All right. So here we are, and we wanted to talk about quantum computing and the new course. But what I created is, can you combine the two? And it seems like yes. So here it is. So I created the course. Now, please disregard all the blah blah because it has to be there. And I'm trying to have some people get them hooked and learn that, look, it's now I know that the way to position this is it's the future and be prepared for the future. When I started teaching it the very first time, I'm ashamed, but I really didn't know that there are no applications. I found out only on the second day. So that's not the way to position, I'll teach you something. There was a science fiction story where the guy got very drunk with a time traveler, and together they got so drunk that the time traveler taught him a new profession. The problem was that profession was repair of time travel machines, and being stuck in his 20th century, he didn't have what to repair. Well, that's similar. This quantum computing has very few applications, but what you can do, because people invest billions of dollars in them, you can prepare for the future, and that is the outline of how you can prepare. But the really interesting part comes at the bottom. And it says when you want to combine, there are two ways. Who needs whom? Okay. Well, there would be a good reason to combine. AI needs computing power, and quantum computers do some good things. So can we help them? Well, the fact that AI needs huge computational power, that's Sam Altman. He should look into that maybe to improve his company, but definitely not something that we would do. What I saw is that you use AI to improve quantum computing. And how? Well, you can predict some of the outcomes even without running the experiments. That's what I saw. I was listening to a lot of lectures from IBM. They have, by the way, they have a weekly webinar at exactly the same time as we have our weekly webinar, but they record it just as we do. So that's an outline of what you can do. You could do quantum machine learning, okay? And you would train models faster, but you also can do quantum data processing using AI. That's where AI would be for quantum. All right, so we connected the two, and there is a lot to learn. I feel that Andrew Ng already told us one important thing. He said, guys, you're looking for a lifetime of learning. There is today no way to get out of it. If you want to be something or anything with AI or without AI, guys, well, you have to learn every day. And that agrees with my life philosophy, which I started quite a long time ago. Um, so, yes. There is more reason to learn with this quantum computing. All right, so we covered all of that. And one last thing that I saw recently, well, two last things that I saw recently, is that Codex is announcing new things, or ChatGPT is announcing new things. And there were two things. First of all, you can now integrate that. Before, it ran somewhere in the background. You gave Codex access to your code, and it would create pull requests. So you have your programmers and the seller, and they, after 10 minutes, send you a pull request with all tremendous improvements. That was a couple months ago. Now they integrated it with all of the tools, and I checked. It seems, yeah, all the tools. I checked IntelliJ, but there is a plugin to use ChatGPT Codex everywhere. And just today came another announcement. Here it is, right? OpenAI. It says GPT real time on the API level. So it seems like you can build a very useful voice agent. What's the problem with voice agents is that they are too slow, right? And too slow means 1/10 of a second. That's already too slow. And now with that, it seems like you can build real time, which, it agrees with one important philosophical approach. And what's that? Well, Sam Altman just recently said that it used to be that you build your startup on some deficiency of AI, and you think it's the way into the future. And that he said 90% of startups were being built that way. And then he said recently it's changed, and he does have visibility into what the startups do. And instead of that, it's the opposite. It's 90% of the startups build on the hope that AI will become better. You don't have to improve any little thing. You build your vertical applications, and you keep in mind that AI will keep improving all the time. Well, that's yet another improvement. So you used to imitate speed by doing this, by caching the input as or the output as it was coming. So you send every word as you get it, and you create the impression of fast thinking. Well, you don't have to anymore. If you build a big system that way, well, with OpenAI going real time, you don't need it. All right. And the last, really the last thing that I want to show is a world of hacker news. And that is because, so I have three loves. I love hacking, and I'm writing a book about AI and security, and the other two are well known. So I saw a very interesting letter is that there is a law in the making, but very close, that US will be allowed to hack anyone they want. Now that is different from before, right? Before only Russians would hack anyone they want, or Chinese would hack anyone they want, or North Koreans would do. But now US saw that, okay, we have pretty good hacking group at FBI, but it's only in one organization, and they created wonderful tools like Hydra, but or Ghidra, I think, but the US private sector was not involved. So what happened is that if the president says, hey, attack this country and we will pay you, you're allowed to. How about that? Well, they would only imitate Russian, but it would be very efficient if I'm to compare to what I know about very little that I know about the history, but I know that America, when it started in the Second World War, had very little air power, and within half a year, it created an amazing amount just because American private sector is something that the dictators cannot imitate. All right, so that's where it is. That's the letter. By the way, it's from a very, very good source called uh, Patrick Gray. That's him. And he writes and he also talks, but what he says is that private sector cyber operators would be allowed to hack foreign cybercrime enterprises that target American citizens and infrastructure under new legislation. How about that? That will be a fun war to have. Of course, wars are no fun, and they shouldn't be. But given that they are, why don't we be the best? That's what he is saying. All right, that covers all the exciting news, but now we have that. Okay, so here is a quantum webinar from Z-Wave. Yes, Z-Wave is a very interesting organization, and I'm very happy that you mentioned it. Okay, this takes us a little bit back to our conversation, but Z-Wave is also, it's a public company, and I think its stock goes up and down. What's important is that they are not a generic quantum computer company. Okay, they are built on a different approach. So it is a combination of quantum computing and regular computers. And it's a hybrid computer, which some people say is really the future. And they are for just a few specific applications, even fewer than quantum computing in general. What are these? These are special type of optimization problems like coloring the surface in multiple colors where there are too many combinations. Too many, there's a word in computing for that. But that's one of them. And planning. So very specific applications, but that's interesting. So I'm clicking on that. Okay. And I see it's coming up. Optimizing aircraft utilization must be one of the things. And what I will do is it's really very interesting. What I will do, I just keep it here and not kill it, and I will subscribe. I want this webinar. Okay. Now, marquee systems and web, that is something that I don't know. If you want to explain, since we're finishing now, then please write. But I think we covered. I will review what we covered. So first of all, there is a new course about agentic with the better understanding. It's not a game, not for everybody, but it gives you better understanding of what you already begin to understand. Then there is a Milvus scalable vector database, which is, some people say, is the most popular, but it's not for everyone. It's for people who need billions of entries in their databases, and an alternative is SQLite with FAISS. Then there is exciting area of quantum computing, even though it is in the future. I don't think still. You know what I say is not quite right, because D-Wave boasts exactly that practical application in this very limited area. But since that is not a generic quantum computer, they kind of don't compete. Okay. And then I showed you a course. Well, if I am able to sell this course to anybody, like, guys, you need to position yourself for the future, then I'll tell you that yes, I got a student. And then amazing thing, the codex gives one more step, and you can write more code or use AI to write code. And if you want to become a private hacking enterprise and at the command of the president attack something, then watch that law. And then generally you can subscribe to Patrick Gray. It's called Risky Biz. So what I will do is just mention this. Risky Biz. That's all you need to find him. He is a great guy. Okay. Newslink. Newslink. Well. Uh, Newslink. Yeah, well, really, all Newslink comes from the page by Andrew Ng, but I'm surprised that it's not there. You're right. I don't see which news link. So Lance, if you can give me that link, it's not here, right? It's somewhere. I don't know which one. That is actually I don't do, but I'll tell those who do it. Yeah, America wants to have the planet, but I wonder how does that compare to Peter Gray? In any way, it's useful, very good. I will save that, and I will update our next webinar. So guys, thank you very, very much. I wish you a great weekend and a great year coming up. The last entry in the chat is your course from IBM Kisket. Now, my course is a combination. It's not only that, but yes, it is part of what they do. Now, what they do also changes. It was changing all the time. You try to include pieces of that course and then it changes. So everything is a moving target. All right. So thank you very much. And next time we'll talk about all the exciting things that you suggested. All the best.